Hello, and welcome to this course on using Python's append method. Lists are frequently used in Python programs that work with collections of data, and append is one of the most commonly used methods to work with lists. So in this fairly short course, you'll learn some of the best ways to use append. To see why this is useful, let's start by looking at the Python list. As I mentioned, it's common for a program to work on collections of data. The list is one of the most common data structures used to store and access those collections in Python programs. And the append method is the primary way data elements are added to a list. So if you're wanting to learn how to properly and effectively use the append method, then this is the course for you. Once you've completed this course, you should be able to write Pythonic code using the append method. Use the append method to populate lists in a for loop. Learn a popular alternate way to populate a list called list comprehension, and learn how append can be used in other types of data structures, such as arrays and double-ended queues, also known as DEQs. This course is related to a tutorial based on Leodanos Ramos called Python's Append, Add Items to Your Lists in Place. And I do follow it pretty closely. So feel free to follow along with that tutorial as you go through this course. These are the software tools I use in this course. If you use other programs, then things will look a little bit different than what you're familiar with. For my program files, I use Visual Studio Code. I do have all of the code examples in the slides, but I'll probably describe the examples in VS Code. All of my code files are available by a link in this course, so you'll have both the slides and the actual files to refer to when wanting to look back at the examples. I'm working on a Mac, and I use iTerm for my terminal shell. For other systems, you might be looking to use another terminal, or maybe something called a command shell or PowerShell. For interactive Python, I use a REPL called PTPython. I like the way its syntax coloring looks in these lessons. So let's get started by looking at the basics of the append method. In this lesson, you'll see the basics of using the append method. The append method takes an object as an argument and adds it to the end of an existing list. For example, suppose you create a list and you want to add another number to it. You would do so by using the append method by first typing the name of the list, followed by a dot, then the call to append, putting in parentheses the object you wanted to add. And now you can see that 4 has been added to the end of the list. In Python, the elements of a list can be any type of object. And append can be used to add any type of object to the end of the list. So you can start with a list of integers, add another integer, then maybe a string, and then a decimal number. So any type of object you have to add to the end of the list, you can use append to do that. One way to interpret what append does can be through the use of slicing. You can start with a list, and then use a slice operation to extend it. So this notation will have the same effect as append. So what's happening here? You're taking a slice from numbers, in this case from 3 to the end, and then assigning that slice to an iterable, in this case a list containing a single element 4. Since there is nothing at index 3 yet, Python unpacks this iterable and places the individual items at the end of the list. However, you shouldn't take this interpretation too literally, because append only adds a single item to the end of a list. But using this slice operation will lead to different type of results. So again, I'm going to take a slice from positions 3 to the end and set that slice equal to a longer iterable. Since numbers doesn't have any elements there, Python will add them to the next positions in order in this list. So this list was extended by 3 elements to make room for 4, 5, and 6. That's using slicing. The append method doesn't function this way. If I try to append, helps if I type it right, numbers.append. If I try to append a list to the end of the existing list, we get a list of size 4, with the 4th element being that list, the first 3 elements still being those integers. So again, don't take this slice interpretation too literally. It only makes sense if you're adding an iterable with a single element to the end of the list. In the next lesson, you'll try to clear up some other misconceptions some programmers have when using append. In this lesson, you'll see 2 common misconceptions about the append method in the hopes that you won't try to use append the wrong way. First is that append only adds a single element to a list. Recall what you saw in the last lesson. If you create a list, and try to append another list to it, you don't get a new list with 6 elements, you get a new list with 4 elements, the last element being the list you just appended to the original list. See another example. Here you can create a variable for the original list and what you want to append to it, this time as a tuple, but it doesn't matter. Append still treated the tuple as a single item and added that as a 5th item to the list. This doesn't recreate the effect that the slice operation in the last lesson demonstrated. To do that, you'll need to use the extend method. This method adds elements from the argument provided as individual elements added onto the list. So here, if you again create a list, and this time use extend with the list you want to add on, you indeed do get a new list with the 6 elements you were expecting. And you can extend your list with a tuple, and it will again have the same desired effect, a new list with individual elements for what you were extending onto the original list. So use extend, not append, when you want to add multiple items to a list, which was the behavior you saw with the slice operation before. Another thing to remember is that append doesn't return a list to use. Append does its work in place. That means it actually modifies the object you call it on. It doesn't return a new or modified version of the list. Technically, it returns none, but that basically means you shouldn't plan on using it as if it's going to return something meaningful. So look at this. You can create a list, and while calling append to it, save the return value to a variable, but when you try to inspect that variable, you don't see anything because it's a reference to none, which basically means it's not a reference to anything meaningful in this context. If you want to see the modified list, that's still in X. X itself was modified. The work was done in place. So again, don't try to use any return value from a call to append. Don't even save it. The list you use it on is being modified by adding the new element to the end of that same list. We call that doing the work in place. Next, we'll look at how append can be used inside loops to populate a list. In this lesson, you'll see one of the most common uses of the append method, which is populating a list from within a loop. A very common task in Python, and other programming languages for that matter, is to create a list iteratively. Here, you'll see how to do that using append inside a for loop. And in the next lesson, you'll see how that's done with something called list comprehension. But let's start with the for loop. To populate a list this way, you create a for loop which will iterate over the way you want to create each element. Then, in the same loop, call append to add that element to the existing list. Here is one example, creating a list of square roots of a collection of values. This function is going to operate by taking a list as an argument, saved to the parameter numbers, containing the numbers you want to take the square root of. Note that since we are going to be using a square root function, you should import Python's math module, which has that and many other useful mathematical functions. Before the loop begins, you create an empty list and save that to a variable. This is the list you're going to populate, one element at a time, each time the following for loop is executed. In this case, you're going to find the numbers to take the square root of in the collection provided in the parameter numbers. You need a variable to refer to each element in that collection. Here, it's called number. What do you want each list element to look like? Well, here it should be the square root of the number you're currently looking at. So you compute that number and append it to the existing list. You do this for every number provided in the argument. Then, outside the for loop, after it's completed, and it's very important to make sure this is outside the loop and not in it, you return the populated list. As an example, let's see how this will perform with a list of the first 9 perfect squares. Each one at a time, will have its square root taken, and then that value will be appended to the end of the list called result. So first 1 will be put in the list, then the square root of 4 is 2, will be appended to result, and then 3, and then so on. And the result is then displayed. To see this, let's run this script in a terminal window. It's called show square roots 1.py. So we run this, and here you can see the numbers in that list generated by the append method being used inside the for loop. This is a very common operation. So common that Python has a different syntax to perform the same action. It's called a list comprehension, and you'll see that next.